Tonight, we follow a quiet journey across the open sea, a time before maps, before GPS, before satellites. Tonight, we go back further than all of that, back to a time when the only map a sailor had was the one they carried inside themselves, when the only compass was the sky above, and the only road was the shape of a wave moving slowly through deep water. So dim the lights a little more. Settle in. Let the weight of the day lift off your shoulders like fog burning off a harbour in the early morning, and let's ease into tonight's story together, because what we're about to explore is one of the most astonishing, quietly beautiful things that human beings have ever done. It is the story of how sailors, ordinary men and women, young and old, working in wooden boats that creaked and swayed, found their way across the widest, most featureless expanses on the surface of this planet, without instruments, without written directions, without anything you or I would recognise as a tool of navigation. Just the stars, just the wind, just the slow, deep, rhythmic pulse of the ocean beneath them, and the knowledge, passed down like a gift, whispered from teacher to student, from elder to child, from one generation's hands into the next. A living library of the sea carried not on paper, but in the mind and the body and the bones of those who had learned to truly listen to the world around them. This is the story of how they did it, and it begins, as all good journeys do, at the very beginning. Part 1, the boy who didn't know where he was going. Picture him now. He's young, maybe 15, maybe 17 years old. His name doesn't matter for our purposes tonight, but let's call him Koa. It's a good name. A Pacific name, a name that belongs to the sea. Koa has grown up on an island, not a large island. In fact, from the highest point on his island, a gentle rise of land covered in wind-bent palms and dry grass, you can see the ocean in every direction. The island is small enough that the sound of waves is never entirely absent, never entirely quiet. Even at night, lying on a mat in his family's open-walled dwelling, Koa falls asleep to the soft percussion of water against sand and coral. He has heard it every night of his life. He knows the ocean the way you know the sound of your own heartbeat. It is simply there, constant, always present. But knowing that the ocean exists and knowing the ocean, truly knowing it, are two very different things. And on the morning that our story begins, Koa is about to learn that difference. It is before sunrise. The sky above the island is still dark, though the stars along the eastern horizon have begun to soften very slightly, their edges blurring, losing their sharpness in the first pale suggestion of coming dawn. The air smells of salt and something green, the smell of the island itself, the breath of the palms and the wet sand and the coral reef that rings the shore like a natural wall. Koa walks down to the water. A canoe is already there. It is the double-hulled vessel, two long narrow hulls connected by crossbeams and a central platform, and it is considerably larger than anything Koa has sailed before. The hulls are carved from tree trunks shaped with stone adzes into smooth hydrodynamic forms. A sail made from woven pandanus leaves is folded neatly against the mast, waiting. The whole structure sits low and quiet on the calm water of the lagoon, held in place by a single rope looped around a coral rock. Standing in the canoe, adjusting the lashings on one of the crossbeams with practiced, unhurried hands, is an old man. His name is Rua. He is the navigator. He is not a large man. He is not physically imposing in any conventional sense. But there is something about the way he stands, completely still despite the gentle rocking of the canoe, that makes him seem anchored to the world in a way that other people simply are not. His eyes are deep and very calm. They are the eyes of someone who has looked at the horizon more times than they could possibly count, and found it every time to be exactly where it should be. Koa steps into the canoe. Rua glances at him briefly, then returns to his lashings. "You will not need to know where we are going," the old man says quietly. Not unkindly, simply as a statement of fact, as plain and unhurried as the first breath of the morning breeze coming off the water. Koa blinks. "Then how will I know when we arrive?" Rua ties off the last lashing. He straightens up slowly, and for a long moment he looks at the horizon. Still dark, still featureless, still offering nothing to the untrained eye but the simple flat line where water meets sky. "You'll know," he says. "You'll know when the ocean tells you." And with that, he unties the rope from the coral rock, and they begin to move. This is where our story truly starts. Not with the destination, because the destination for now is beside the point. The journey is the lesson. And the lesson for Koa, for us, for all of us listening quietly in the dark tonight is this. The ocean is not empty. It has never been empty. It is full of information, full of signals, full of the slow, patient language of the natural world, a language that human beings once knew how to read as fluently and as naturally as they read the expressions on each other's faces. What Rua is going to teach Koa over the days and weeks and months that follow is not a trick. It is not a shortcut. It is not a clever workaround for the absence of a map. It is, in fact, something older than maps, something deeper than maps. It is a way of being in the world, a way of paying attention that turns the whole sky and the whole sea into a single, coherent, legible place. And it begins, as all things begin in the Pacific, with the stars. Part 2, A Roof of Fire. The first night out on open water, Koa cannot sleep. This is not unusual. It is in fact entirely expected. The open ocean moves differently than the lagoon. There are long swells, gentle, slow, deep rollers that come from somewhere very far away and lift the canoe in a gradual, undulating rise and fall, like the slow breathing of something enormous. The canoe does not rock violently. It does not pitch or lurch. It simply rises very slowly and then descends very slowly in a rhythm so unhurried that it feels almost geological, like a continent shifting one patient millimeter at a time. But it is new, and new sensations, however gentle, have a way of keeping you awake. Koa lies on his back on the central platform. The sail above him fills and slackens gently in the warm night wind. And above the sail, above everything, is the sky. He has seen the stars before, of course. Everyone has seen the stars, but he has never seen them like this. Out here, away from the island and its cooking fires and its small golden lights, the darkness is complete in a way that land dwellers rarely experience. And into that darkness, the stars pour themselves with a generosity that is almost overwhelming. There are thousands of them, tens of thousands, more than the eye can easily take in at once, so many that the sky loses its sense of depth and simply becomes a surface, a ceiling of light, a vast, curved, glittering dome that extends from one horizon to the other and fills every inch of available space with something that glows. The Milky Way stretches overhead in a great arc, not the thin, faint smear that you might catch a glimpse of from a suburban backyard. No, this is the real thing. Dense and bright and almost three-dimensional, a river of ancient light so wide and luminous that it casts faint shadows on the deck of the canoe. It looks less like a collection of distant stars and more like something living, something breathing, a road of a kind drawn across the sky. Koa stares at it. Rua comes and sits beside him, cross-legged, moving with that same unhurried certainty. He looks up at the sky without saying anything for a long moment. Then he begins to teach. Every star, he says quietly, rises in the same place every night. Not the same clock time, the same place. That one. He points to a bright, steady point of light low on the eastern horizon. Rises there. Always. In that house, in that direction. In the old Polynesian way of understanding the sky, the entire horizon was divided into what navigators called star houses. Specific positions along the horizon where particular stars rose and set, night after night, season after season, with the reliability of something that has been doing the same thing since long before any of them were born, and will continue doing it long after all of them are gone. The Hawaiian star compass, one of the most sophisticated versions of this system, divided the horizon into 32 houses, each associated with a specific star or constellation, each representing a direction of travel. Master Polynesian navigators memorized the rising and setting positions of hundreds of stars. The Hawaiian star compass divided the sky into 8 families of stars occupying 32 houses, with each house indicating the position of stars rising and setting at the horizon. Think about what that means for a moment. Hold it in your mind while you breathe slowly in the dark. 32 points of direction, hundreds of individual stars, each one memorized, each one placed precisely in the living, breathing atlas of the night sky that the navigator carried, not in a book, not on a scroll, not inscribed on any surface that could be lost or damaged or soaked through by salt water, but in their own mind, their own memory. The most durable, the most portable, the most truly indestructible container that has ever existed. Rua begins pointing out specific stars. There is Hokulea, Arcturus, in the Western astronomical tradition, which passes almost directly over the Hawaiian Islands. Hokulea passes almost directly over Hawaii, making it a homing beacon for northbound bound voyagers. For a navigator sailing north toward those islands, Hokulea is not merely a beautiful star in the sky, it is a destination marker, a beacon, a star that says simply, quietly, "Follow me, I am going where you want to go." There is the Southern Cross, Crux, low in the southern sky, its 4 bright stars arranged in a tilted diamond with a 5th fainter star completing the pattern. By extending the line formed by the Southern Cross's stars, sailors could accurately determine southward orientation, enabling them to traverse unfamiliar seas with confidence. There is Orion, the great hunter, whose belt is made of 3 nearly identical stars in a perfectly straight line. Those 3 stars rise almost exactly due east and set almost exactly due west, regardless of where in the tropical Pacific you happen to be standing, which means that if you watch where Orion's belt rises above the eastern horizon at the beginning of the night, you know with quiet certainty which way east is, and if you know east, you know everything else that follows. North, south, west. The whole compass rule drawn for you in fire against the darkness of the sky. And there, always, is the North Star, Polaris. The North Star stays in one place at night, while other celestial objects travel across the sky. This makes it a trustworthy benchmark for figuring out a ship's bearing. This is the thing about Polaris that makes it so valuable, so beloved by navigators across so many different cultures and centuries. Every other star in the northern sky moves. They rise, they arc slowly overhead, they set, they rotate in great circles around the celestial North Pole. You can watch the whole sky wheel slowly overhead if you stay out long enough, or the way a wheel turns on its axle. But Polaris sits almost exactly at the axle itself, it barely moves at all. While all the other stars trace their slow arcs, Polaris simply hangs there, steady and patient and utterly reliable, like a lantern hung in the exact north of the sky by someone who wanted to be absolutely certain you could always find your way. The Phoenicians, among the earliest known master mariners of the ancient world, sailing the Mediterranean and beyond as far back as around 2000 BCE, placed such importance on this star that the Greeks named its constellation after them. The most important star to the Phoenicians was the pole star of the Ursa Minor constellation, and by way of a compliment to their seafaring skills, the Greek name for this group was actually Phoenica, or Phoenician. The Vikings called Polaris the guidance light. The North Star was used by the Vikings, and they referred to it as the guidance light while they were on the move. In Arabic astronomical tradition, it was called Al-Qutb al-Shamali, the northern pivot, the pivot of the sky, the still point around which everything else turns. And here is something that the great navigators understood intuitively, something that we can verify today with instruments and mathematics. The height of Polaris above the horizon is exactly equal to your latitude on the surface of the Earth. Polaris's position helps sailors determine their latitude, as its angle above the horizon matches the observer's latitude. The closer one journeyed to the North Pole, the higher Polaris appeared in the sky, which means that if you know how high Polaris sits above the horizon, and a skilled navigator could measure this with nothing more than the width of a few fingers held at arm's length, you know how far north or south of the equator you are. You know your latitude. You can hold it in your mind like a number, a fact, a coordinate, and you can sail along that latitude, keeping Polaris at the same height above the horizon, with the comfortable confidence of someone following a well-marked trail. The ancient Arab navigators developed a simple instrument for measuring this called the kamal, nothing more than a rectangular piece of bone or wood with a string attached, knotted at specific intervals. The kamal itself was simple to construct. It was a rectangular piece of either bone or wood which had a string with 9 consecutive knots attached to it. You held the board up and stretched the string to your nose, and the position of a specific knot against your teeth told you the altitude of the star. Crude by modern standards, but accurate enough to cross the Indian Ocean. Accurate enough to navigate from the Persian Gulf to the coast of China and back year after year, following the monsoon winds with the calm assurance of someone who has done it before and expects to do it again. Koa listens to all of this. He stares at the stars. He tries to hold the shapes in his mind, the rising points, the setting points, the houses, the paths, the heights above the horizon. It is at first overwhelming. There is so much sky. You will not learn this in a night, Brewer says, as though he has read Koa's thoughts. You will not learn it in a month, but you will learn it. He pauses. Every night you will lie here and look at the sky, and the sky will begin to look familiar. The way a face looks familiar, the way a voice sounds familiar. You will not need to think about it. You will simply know. This is the nature of deep knowledge. The kind of knowledge that goes below the level of conscious thought and becomes part of the body itself. The navigators of the Pacific did not navigate by consulting a mental reference book, flipping through remembered pages to look up which star to follow. They navigated the way you walk, with an automatic embodied fluency that doesn't require deliberate thought, because it has become part of how you exist in the world. Polynesian navigators spent years learning star maps. Some could identify over 200 individual stars and knew their seasonal movements. 200 stars, not just their names, their rising points, their setting points, their seasonal variations, their relationships to one another. The way one star's position tells you something about another star's position, the way letters make words and words make sentences, and sentences make a story you can read in the dark. The most important time of day for those navigators, incidentally, was not the middle of the night. The most important time of day for ancient navigators was just before sunrise and just after sunset. This is the transitional moment, the brief window when you can see both the stars and the horizon at the same time, when the sky is dark enough to read the stars clearly, but the horizon is still defined well enough to measure a star's height above it precisely. Before sunrise and after sunset, the world offers navigators a gift. For a few precious minutes, the sky and the sea are both readable at once. Koa begins to understand this on his first night out. He watches the eastern horizon soften from pure black to the deepest blue, and he sees how the stars near the horizon become legible in a new way, still bright, still clear, but now set against a visible background. He can see with his own eyes exactly where the star sits above the line where sky meets sea. He watches the guidance light, Polaris, and he tries to judge its height. He holds up 3 fingers at arm's length. He looks at the gap between the horizon and the star. Rua watches him without comment, but there is something in his posture, a very slight softening, that might, if you are paying close attention, look something like approval. The night deepens, the stars wheel slowly overhead, the canoe lifts and falls on its long, unhurried swells, and Koa, for the very first time in his life, begins to have the experience of reading the sky. Part 3. The wind has a memory. By the 3rd day out on the open ocean, Koa has begun to notice something he cannot quite put words to. The wind is different. Not different in a dramatic, alarming way. Not stronger or weaker in any way that would concern him. But it has a quality, a consistency, that the wind near shore never had. On the island, the wind was restless. It shifted. It came off the land in puffs, carrying the smell of vegetation and soil. It came off the ocean in gusts, unpredictable, varied, sometimes warm and sometimes surprising in its coolness. Out here, the wind simply blows, from the same direction, with the same soft, unhurried authority, day after day. It has been blowing this way since before your grandfather was born, Rua says one morning, watching Koa feel the wind against the side of his face with an expression of quiet concentration. This is the trade wind, and it is one of the most remarkable features of the tropical ocean. So reliable, so consistent, so utterly dependable that mariners for thousands of years built their entire concept of long-distance voyaging around it. Trade winds are generated by a beautifully simple mechanism of planetary physics. Near the equator, the sun heats the air intensely, causing it to rise. Cooler air flows in from north and south to replace it. The rotation of the Earth, the Coriolis effect, deflects this flowing air, bending it so that in the northern hemisphere it arrives from the northeast, and in the southern hemisphere from the southeast. The result is 2 broad belts of steady, reliable wind blowing consistently toward the equator from the tropics. Winds that European sailors later named the trade winds precisely because they were so useful for commerce, for trade, for getting where you needed to go efficiently and safely. The easterly winds that blow near the equator are called trade winds, because sailing ships on trading voyages followed these winds to blow them across the oceans. For ancient Pacific navigators, the trade winds were not merely useful, they were foundational. They were the first thing a young navigator learned to recognize and trust, the steady, salt-tinged easterly breath that blew across thousands of miles of open Pacific without significant interruption for months at a time, providing a constant directional reference that supplemented and confirmed everything the stars were saying. But wind is more than just a directional tool. Rua teaches Koa to read the wind with his whole body, not just with his face, not just with the skin of his cheeks and forehead, which can tell you the general direction a wind is coming from, but with everything, with the fine hairs on his arms, with the way his clothing moves, with the subtle pressure he feels against one side of his body versus the other. "Close your eyes," Rua says one afternoon. "Tell me where the wind is coming from." Koa closes his eyes. He stands on the platform, arms slightly out from his sides, and he breathes slowly. The wind presses against his right ear, against the right side of his neck, against the back of his right hand. "Northeast," Koa says. "Open your eyes." Koa opens them. Rua says nothing, but the slight angle of the sail against the mast, the way the woven pandanus cloth has filled and trimmed itself relative to their course, confirms it. Northeast. Correct. "Now," Rua says, "tell me what is different about today's wind from yesterday's wind." This is a harder question. Koa thinks about it carefully. "It is a little warmer," he says finally, "and it smells different, more like rain." Rua nods very slowly. "Rain is coming," he says, "from the east, 2 days, maybe 3. Ancient sailors relied heavily on these natural phenomena to chart courses across vast oceans. Recognizing predictable wind behaviours allowed explorers to optimize their routes and conserve resources. Beyond the trade winds, the ancient navigators of the Pacific and Indian Oceans had to understand a more complex and seasonal phenomenon, the monsoon. Monsoons are among the most dramatic examples of predictable large-scale wind patterns on Earth. In the Indian Ocean and Southeast Asian seas, the wind reverses direction entirely between summer and winter, blowing strongly from the southwest during one season and from the northeast during another. Driven by the differential heating of land and sea, monsoon cycles are seasonal monsoons that can significantly alter wind patterns, impacting voyage planning. Understanding these variations was essential for ancient seafarers. Arab sailors had understood and mastered the monsoon system centuries before European navigators reached those waters. Beginning around the 800s CE, Arab navigators sailed the Indian Ocean from the Persian Gulf to Madagascar and beyond to China, timing their departures with the precision that comes from generations of inherited wisdom. Beginning about 800, Arab navigators sailed the Indian Ocean from the Persian Gulf to Madagascar and beyond to China. They knew that you departed in one season to take advantage of one monsoon, and you returned in another season on the reversed wind. Missed the window, and you waited months for the next one. Hit it correctly, and the wind carried you thousands of miles as naturally and efficiently as a leaf carried by a river. The seasonal wisdom encoded in this knowledge was passed from navigator to navigator not in written tables or almanacs, but in the accumulated oral memory of a maritime culture. An Arab navigator in the 9th century knew the monsoon patterns not because he had read about them in a book, but because his teacher had known them, and his teacher's teacher before that, going back through generations of people who had sailed these waters and paid attention to what they found. Knowledge as inheritance, knowledge as legacy, knowledge as the most precious cargo any ship can carry. Back on the canoe, Koa sits with his eyes closed and the wind against his face, and he tries to hold all of this in his mind without forcing it, without gripping it too hard. The navigators understood intuitively that this kind of learning cannot be squeezed into the mind by effort alone. It must be received. It must be allowed in slowly, the way water permeates fine sand, not by pressure, but by patience. 2 days later, the rain comes from the east exactly as Rua said it would, and Koa, for the first time, feels what it is like to know something true about the world. Part 4. How the ocean speaks. There is a practice that the navigators of Micronesia used, particularly the navigators of the Marshall Islands and the Caroline Islands, that sounds to modern ears almost impossibly subtle, almost impossibly intimate. They would lie down on the hull of the canoe, not to rest, not to sleep, but to feel the ocean. The hull of a traditional outrigger or double-hulled canoe is a thin shell of wood, flexible enough to transmit the movements of the water around it with extraordinary fidelity. When you press your body against the hull, when you lay your chest or your stomach flat against the wood, you can feel the ocean's motion not just as a general up and down, not just as the obvious rocking that anyone standing on the deck would notice. You can feel the individual swells, their direction, their period, their subtle character. One Marshallese navigator preferred to sail after sunset, allowing him to feel the up, down and sideways movement of every swell. That's how the Marshallese navigate, he said. They navigate with their stomach. Navigate with their stomach. Let that settle for a moment. The ocean is not flat, it is not still. It is a three-dimensional, constantly moving medium animated by the wind and shaped by the land and organised at the deepest level by enormous swells that travel across entire ocean basins, with a consistency and a predictability that mirrors, in its own way, the predictability of the stars. Ocean swells are born in storms. A distant weather system, perhaps 1,000 miles away, perhaps more, churns the surface of the sea into chaos, but the energy of that chaos doesn't stay chaotic. It organises itself slowly into long, ordered waves that radiate outward from the storm's centre in all directions. By the time these waves have travelled 1,000 miles from their source, they have become something quite different from the churning confusion they began as. They have become swells, long, smooth, deep rollers that move through the water with almost no relationship to the local wind, carrying the energy of their distant birth across enormous distances. Ocean swells are generated by distant weather systems and travel across the Pacific with remarkable consistency. Experienced navigators could read these swells by feel, lying in the hull at night, sensing the canoe's movement in multiple directions simultaneously. In the open Pacific, there are typically 2 or 3 dominant swell systems operating at any given time, each travelling from a different direction, each with its own period and character. A master navigator lying in the hull can identify each of these swell trains separately, can feel the way they combine and interact, the way one lifts the bow slightly while another lifts the stern, the way the canoe's complex motion is the sum of all these different forces acting on it simultaneously. This is not a skill you are born with. It takes years to develop, but once you have it, once you can distinguish by feel alone between 3 different swells moving in 3 different directions, you have something extraordinary. You have a positional reference that works even when the sky is overcast and the stars are hidden. Even in the middle of a cloudy night, the ocean is still telling you where you are, because swells interact with land. Polynesian navigators could detect an island up to 200 kilometers away by reading how ocean swells refracted around it. An ability so precise that European scientists initially refused to believe it was possible. 200 kilometers, an island still invisible below the horizon, still too far away to see even from the top of a mast, but already announcing its presence in the language of altered swells. As an ocean swell approaches an island, it bends around the island the way light bends around an obstacle. On the far side of the island, the leeward side, the side sheltered from the prevailing swell direction, the water is calmer. The swells are diminished, and in that diminishment, there is information. A navigator approaching from downwind can feel the growing calm, can feel the way the expected swell train begins to flatten slightly, to lose some of its rhythm, to arrive from a slightly different angle than it should. And from that disruption, from that almost imperceptible change in the way the ocean moves, they can infer the presence of land long before they can see it. The people of the Marshall Islands developed a remarkable physical tool for teaching this knowledge to younger navigators, the stick chart. The charts were composed of wooden sticks. The horizontal and vertical sticks act as supports, while diagonal and curved ones represent wave swells. Cowrie or other small shells represent the position of the islands. The information was memorized and the charts would not be carried on voyages. This is the part worth pausing on. The stick charts were teaching tools, learning aids. You studied them on shore, you committed their lessons to memory, and then you left them behind. Because on the ocean, there was no point in carrying a chart you couldn't consult while lying in the hull feeling the swells through your stomach. The chart had to be inside you. The map had to be the body itself. Rua shows Koa how to lie in the hull. It is an awkward position at first. The wood is hard. The motion of the canoe is disorienting when you're this close to it, this intimate with it. But after a few minutes, after Koa stops fighting the motion and allows himself to simply receive it, allows the canoe's movement to pass through him rather than pressing against it, something begins to shift. He can feel it. 2 separate pulses, 2 different rhythms, subtle but distinct, crossing each other at a slight angle. One coming steadily from the east-southeast, the long trade wind swell born in the open Pacific, and another, shorter, slightly choppier coming from the north, a local swell generated by a weather system somewhere upwind. "I feel 2, Koa says quietly, his voice low, almost a whisper. "Good," Rua says from above. "Now, which one is changing?" Koa holds his breath, focuses. The eastern swell is steady, consistent. It has been this way all day, a reliable pulse, but the northern swell is different, slightly softer than it was this morning. The crest's a little more spread out, a little more gentle. The northern one, Koa says slowly, it is getting calmer. A pause. Land is north, Rua says, not as a revelation, not with triumph, simply as a confirmation of what the ocean has already said. The island blocks the swell. We are getting into its shadow. Koa lies in the hull for a long time afterward, not moving, just feeling. Feeling the ocean speak in its slow, patient language. Feeling the message in the water that has been travelling for perhaps hundreds of miles, passing through depths that no light has ever reached, carrying its quiet information all the way to the underside of this small wooden hull, and from there into the chest of one young man learning, for the very first time, to listen. This is navigation, not as calculation, not as technology, as conversety, as relationship, as the ongoing, never-completed practice of paying attention to a world that is always speaking, if you have learned to hear it. Part 5. The roads that invisible rivers make. The ocean is not a single uniform body of water. This is something that surprises many people when they first hear it. We speak of the Pacific Ocean as if it were a single thing, a blue expanse uniform from edge to edge, the same water everywhere. But it is not. The ocean is more like a system of invisible rivers and roads, shaped by temperature and salinity and the great rotational forces of the Earth, carrying enormous volumes of water in specific directions at specific speeds, creating what oceanographers call currents, and what ancient sailors experienced as something both invisible and unmistakable. You cannot see a current by looking at the surface of the water, not directly, but you can feel it, and you can see its effects if you know where to look. Sailors identified currents by determining how cold or warm the water was, as the temperatures of some currents are warm and others cold. Also, some currents appear a different colour because of phytoplankton, or they have floating seaweed-laced edges. Temperature, colour, the floating things at the surface. These were the signs that ancient navigators learned to read as naturally as you or I might read the difference between an overcast sky and a clear one. A sharp change in water temperature, felt simply by dipping your hand over the side, and could tell you that you had crossed from one current into another. A change in the colour of the water, from the deep, almost purple blue of the open ocean to the greener, richer colour of shallower coastal waters, could tell you that land was near. The presence of floating seaweed, particularly the brown, golden-tipped sargassum weed that drifts along the edges of certain currents, was a known landmark of a different kind, a soft, floating road marker that said, "Here is the boundary of this current. Here is the edge of this invisible river." Ocean currents significantly influenced ancient navigation by shaping the routes mariners could safely and efficiently follow. They acted as natural highways, reducing the effort required to traverse vast and often challenging sea distances. Natural highways is a beautiful way to think about it. The ocean, which looks so featureless from the shore, is actually crisscrossed with these invisible roads, some of them thousands of miles long, carrying their water at speeds of 1 or 2 or 3 knots, reliable enough that a navigator who knew them could factor them into their calculations as surely as if they were following a physical path. The North Equatorial Current in the Pacific flows steadily westward across thousands of miles of open ocean. The Kuroshio Current, the Pacific equivalent of the Gulf Stream, flows northward along the eastern coast of Japan, carrying warm tropical water into higher latitudes and moderating the climate of the islands and coasts it passes. In the Indian Ocean, the currents reverse with the monsoons, flowing in one direction during the summer monsoon and the other direction during the winter, which is one of the reasons Arab sailors understood the monsoon system so deeply. The wind and the current were partners. They changed together, travelled together, and could be read together. Just as the trade winds are fairly consistent, the oceans have consistent currents that behave like underwater rivers. Using their knowledge of the location and flow direction of these currents, navigators could better understand how far east or west they were. East or west, longitude. This is the dimension of navigation that bedeviled European sailors well into the 18th century. Longitude, the east-west position of a ship, was notoriously difficult to determine without an accurate clock. European navigators could find their latitude reasonably well using celestial measurements, but their east-west position was often a matter of estimation and hope. Famous navigators of the Age of Exploration, including Christopher Columbus, made significant errors in their longitudinal reckoning that only the fortunate accident of landfall corrected. But Pacific navigators had a different approach to this problem. Rather than trying to calculate longitude as an abstract number, they use the ocean itself, its currents, its temperatures, its swell patterns, as a continuous positional reference. Land waves, which are reflections of currents that rebound off islands, can be recognized from distances as far as 50 miles away. 50 miles. An island leaving its fingerprint in the ocean 50 miles away from its shores, not in any physical, visible sense, but in the subtle, altered behavior of the water around it, readable to those who had spent years learning to feel it. Rua shows Koa how to notice the color of the water. It is mid-afternoon, and the sun is high enough that it penetrates into the top layers of the ocean, illuminating the color of the water below. In the deep open sea, the water is a profound, saturated blue, almost indigo, the color of the sky at the deepest moment of dusk. But off to the northwest, maybe several miles away, the color changes. It becomes slightly greener, slightly lighter, slightly more complex. "What is that?" Koa asks. "Shallow water," Rua says. "A reef, maybe, or the beginning of a shelf." He pauses. We adjust our course. He shifts the angle of the sail slightly. The canoe responds with that easy liquid grace that well-designed boats always have, the sail filling at its new angle, the hulls settling into their new line through the water. Koa watches the color differential on the water's surface for a long time. He watches how it shifts and moves as they change their angle of approach. He notices that the boundary between the two colors is not a sharp line. It is gradual, blurry, more like a slow fading than a sudden change. He is learning to read the sea, and the sea, patient, enormous, unhurrying, is letting him. Part 6. The Creatures Who Know the Way. One morning, Koa wakes before dawn to find Rua standing at the front of the canoe facing east, watching in the sky, not the stars. The swoop, the eastern horizon, is just beginning to pale from black to the deepest, most saturated grey-blue. That colour that is the very first breath of morning, before any colour has actually arrived, before the sky commits to anything, and against that pale grey background, moving in silence, are birds. Not many, 3 or 4. Dark silhouettes moving with purpose against the lightening east. They are flying in a specific direction, not wandering, not circling, not hunting, but flying with the direct, unhesitating purpose of creatures that know exactly where they are going. "Where are they going?" Koa asks quietly. "To feed," Rua says. "They fly away from land at dawn, they go to the open ocean to fish, then they come back." He pauses, watches them go. In the evening they return back human toward land. Every day. Certain seabird species flew out to sea at dawn and returned to land at dusk, marking the location of islands. Some birds rarely strayed far from land, signalling nearby shores. The use of birds as navigational indicators is one of the oldest, most universal navigational techniques in human seafaring history. From the Pacific to the North Atlantic, from the Indian Ocean to the Mediterranean, sailors across cultures and centuries learned to watch the flight of seabirds and derive from it information about the proximity and direction of land. Different birds carried different information. The white tern and the noddy tern, small, delicate, brilliant white birds common throughout the tropical Pacific, rarely ventured more than about 20 to 30 miles from their nesting islands. The sight of these birds, especially in significant numbers, was one of the most reliable early indicators that land was near. Certain seabirds such as the white tern and noddy tern fly out to sea in the morning to hunt fish, then return to land at night. The frigate bird was used differently, and more deliberately. Polynesians used shore-sighting birds, bringing with them frigate birds, who refused to land on the water as their feathers would become waterlogged. When voyagers thought they were close to land, they would release the bird. Picture that for a moment. A canoe on the open ocean, a caged frigate bird waiting patiently on the platform. The navigator, trusting their dead reckoning and their swell reading and their star observations, believes that land is near, though they cannot yet see it. So they open the cage. The bird launches into the air, circles once, twice, oriented itself, and then flies in a straight line, quickly, purposefully, carrying its waterproof, feather-free wings toward the one thing it needs, dry land, and the canoe follows. The Vikings of Scandinavia, sailing the grey, cloud-covered North Atlantic, navigating seas where the sun could be absent for months and stars obscured by weather for weeks, used a similar technique, though with ravens rather than frigate birds. These resourceful seafarers used ravens to discover Greenland and Iceland. If the released bird circled and returned, They knew they had to keep searching, but if it flew in a straight line, they followed it to their new destination. A raven that circles and comes back means no land in that direction. A raven that flies away in a straight line and does not return means it has found something. Land, a shore, a reason to stop flying and land. This is, in its own way, one of the most elegant navigational instruments ever devised. A living creature with instincts and sensory abilities far beyond our own, repurposed as a directional tool. No technology required, just a bird doing what birds naturally do, and a navigator wise enough to pay attention. A seabird with a fish in its mouth was most likely flying back toward land to eat its catch, while a bird with an empty beak was likely flying out to sea to fish. Sailors on open waters followed seabirds back to the shore. Fish in the mouth means heading home. Empty beak means heading out to hunt. A detail so simple, so logical, so beautiful in its practicality that it barely needs explaining once you hear it. And yet it took generations of careful observation, countless sailors watching countless birds over countless voyages, to establish this as reliable, actionable knowledge. Beyond birds, the ocean is full of other biological signs. Certain species of fish congregate around underwater reefs. The presence of specific dolphins can indicate particular current boundaries. Bioluminescent plankton, tiny organisms that glow a cool blue-green when disturbed, light up the water in certain conditions, and their distribution and behavior carry information about currents and water conditions. Polynesian navigators employed a wide range of techniques, including the use of the stars, the movement of ocean currents and wave patterns, the patterns of bioluminescence that indicated the direction in which islands were located, and the air and sea interference patterns caused by islands and atolls. Bioluminescence as a navigation tool, the ocean glowing in the dark, writing its messages in cold fire. Koa watches the birds until they disappear into the growing morning light. Then he turns to Rua. "Which direction did they come from?" he asks. Rua smiles. It is, Koa realizes, the first time he has ever seen the old man smile. "You learn," Rua says. At part 7, when the sky closes. Not every night is clear. This is something the romantic imagination of later centuries often forgot when it thought about ancient navigation. The image of the skilled mariner always under a jeweled sky, always surrounded by perfect, brilliant stars. But the real ocean is more complicated than that. Storms build, clouds roll in, thick and grey and featureless, hiding everything above. For days at a time, the sky can be entirely obscured, offering the navigator nothing celestial to work with. So what then? The answer is everything else. The swells are still there, the currents are still there, the birds are still there, the temperature of the water is still there, the wind, with its direction and its character and its smell there, is still there. The navigator who has been paying close attention to all of these things, building a continuous, updating picture of their position and progress, does not suddenly lose that picture just because the stars disappear. This is the genius of the holistic approach to navigation. No single source of information is relied upon to the exclusion of all others. The stars are backed up by the swells, which are backed up by the wind, which are backed up by the birds, which are backed up by the watercolor and temperature and the distribution of floating material. On cloudy nights, navigators switched to other methods. They never relied on a single source of information. The Vikings had an additional tool for overcast conditions, one that passed into legend before modern science confirmed its existence. The sunstone. Several accounts in the ancient Nordic sagas speak of a solarstein, or sunstone, which Vikings used to determine the sun's position after sunset. For years it was thought to be little more than a legend, but in 2010 a unique crystal was found in the wreck of an Elizabethan ship sunk off the coast of the Channel Islands. After 3 years of intensive study, scientists announced that the crystal made of a calcite substance could indeed act as a navigational aid. The sunstone is a crystal, likely Iceland spar, a transparent form of calcite that has a remarkable optical property. When you look through it at a patch of sky and rotate it, the light changes, it brightens and dims, and the point at which the light is at its most symmetrical, at which 2 bright spots visible through the crystal are of equal brightness, corresponds exactly to the direction of the hidden sun, even when the sun is behind clouds, even at twilight, when the sun has dropped below the horizon. Norse and Viking sailors relied entirely on observational skills and traditional knowledge passed down orally. Their longships were fast and flexible, but open-decked and vulnerable to weather, requiring both courage and precise navigation to make their journeys successful. And those journeys were extraordinary. The Norse sailed from Scandinavia to Iceland, from Iceland to Greenland, from Greenland to the coast of North America, Newfoundland, which they called Vinland, more than 400 years before Columbus crossed the Atlantic. They did this without magnetic compasses, which didn't reach Europe until the 12th century, well after the peak of Viking seafaring. The magnetic compass wasn't introduced to Europe until the 12th century, well after the height of the Viking Age from approximately 793 to 1066 CE. What they had instead was the sunstones, the sun compass, a wooden disc with a central gnomon that cast a shadow, allowing them to track the sun's position throughout the day and determine north, the stars at night, their intimate knowledge of the North Atlantic's weather patterns and currents, and the same bird-watching techniques that Pacific navigators used. During the day, the Vikings used the sun as a primary navigational tool. They observed its position at noon to determine their latitude and used a sun compass, a wooden disc with a central gnomon, to maintain their bearing. In the southern hemisphere, meanwhile, where there is no North Star to serve as the fixed anchor of celestial navigation, the Southern Cross performed a similar role. Its 4 principal stars, aligned in a particular pattern, can be used to find the direction of the South Celestial Pole. The Crux constellation, also known as the Southern Cross, is the most important navigation point in the southern hemisphere that helps to identify the south. It consists of 5 stars that make up a cross. The sky is different in different hemispheres, but the principle is the same everywhere. Find the fixed point, the still center around which all other stars rotate. Measure its height above the horizon. Sail along that height, keeping it constant, and the ocean will carry you where you need to go. On the 3rd overcast night of their voyage, Koa sits in the bow of the canoe and tries to navigate without stars. It is strange. The sky above him is a uniform, featureless grey, and the absence of stars, those familiar lights he's been learning how to read with growing confidence, creates a hollowness that is almost like vertigo. He feels exposed, unmoored, as though the darkness has become too dark, too complete, too absolute. But then he lies down in the hull, and the ocean speaks, the eastern swell steady and reliable, lifting the bow at the same angle it has been lifting it all day. The northern swell, slightly diminished now, less so than yesterday, which means they have moved away from whatever land was creating that shadow. The wind against his right ear, still from the northeast, still with that warm, open ocean quality that smells of nothing but salt and distance. He's not lost. He was never lost. The stars are hidden, but the ocean is not. Koa takes a slow breath, releases it. He knows where he is. Not in the way that a GPS device knows, not with coordinates and decimal points and satellites overhead, but in the way that a person who has paid very close attention to where they have been always knows where they are, continuously, cumulatively. By the accumulation of all the small observations, all the felt sensations, all the red signals that have been building in his awareness since the moment they left the lagoon, he is navigating. Part 8, The Living Library. There is a concept in Polynesian navigation called etak. It is not easy to explain in Western terms because it requires a fundamental shift in the way you think about motion. In the etak system, the navigator does not think of their canoe as moving through a fixed ocean toward a fixed destination. Instead, they think of the destination and the ocean around it as moving past the canoe, which remains, in a sense, still. The canoe is the fixed point. The islands move. This sounds strange at first, perhaps even backwards, but consider it from the navigator's perspective. They cannot see the destination. They cannot see where they are going. What they can see and feel and perceive is everything around them. The stars, the swells, the wind, the birds, and all of those things change as the canoe moves through the ocean. The reference stars slowly shift their rising and setting positions relative to the canoe's course. The swell patterns change as the canoe moves through different ocean regions. The water temperature changes. From the navigator's perspective, all of this change is happening around them. The world is moving past them, while they remain the unmoving center of their perception. The destination is not out there, fixed in space, waiting to be reached. The destination is something that will eventually arrive, will come to them, as the ocean continues to move past. It is a navigational philosophy as much as a technique. A way of being on the ocean that places the navigator at the center of a constantly updating, constantly moving, constantly informative world, rather than as a small point lost in a vast featureless expanse trying desperately to find their way to something they cannot see. Polynesian navigators memorized thousands of star positions, read wave patterns, observed bird behavior, and felt oceanic swells with their bodies. Each island had its own star path, a specific sequence of stars that would guide a navigator from one island to another. Each island has its own star path. This means that the knowledge of navigation was not a single general skill that could be applied interchangeably to any voyage. It was a collection of specific, intimate, detailed knowledge sets. One for each route, one for each island, each one memorized as a distinct thing with its own characteristics, its own star sequence, its own swell patterns, its own bird populations, its own watercolor and temperature signatures. The total body of navigational knowledge possessed by a master navigator was therefore enormous. It was a living library, a vast collection of specific, detailed, interconnected knowledge about the Pacific Ocean, covering perhaps millions of square miles, dozens of island groups, hundreds of routes, thousands of stars, all of it stored not on any physical medium, but in the navigator's own mind, maintained and refreshed through constant practice and regular voyaging. By 1970, Maupiailug was one of just 6 master navigators left, all living on Satawal, or the neighbouring island of Puluwat. Several were already too elderly to go to sea. Maupiailug. This name deserves to rest in the air for a moment. Maupiailug was a Micronesian man from the tiny island of Satawal in the Caroline Islands, an island so small that you could walk across it in minutes. He earned the title of Master Navigator, or Palu, by the age of 18. As he neared middle age, Mao grew concerned that the practice of navigation in Satawal would disappear as his people became acculturated to Western values. In the tradition of his people, the knowledge of navigation was inherited within family lineages, passed from master to student within a closed, sacred educational tradition. To share it outside that tradition was to break a rule as fundamental as any other in the social order. But Maupiailug looked at the world around him and saw what was happening. European contact, westernization, the slow erosion of the old ways. Young men on Satawal who would grow up never learning to navigate the way their ancestors had navigated. The living library, thousands of years of accumulated ocean knowledge, in danger of dying with the last few navigators who still held it. So he made a decision that changed everything. Mao navigated the first voyage of the Hokulea to Tahiti in 1976, sharing his navigational knowledge with others to keep the wayfinding traditions alive. The Hokulea was a 60-foot double-hulled Hawaiian voyaging canoe, built by the Polynesian Voyaging Society as a living experiment in traditional navigation. It was a twin-hulled sailing canoe that sailed 2,500 miles from Hawaii to Tahiti in 1976 without instruments or charts. 2,500 miles, without instruments or charts, guided only by the stars, the swells, the wind, and the knowledge in one man's mind and body. This journey of 6,000 nautical miles took 34 days to complete, but Mao would never rest for more than a few hours at a time. Never rest for more than a few hours at a time for 34 days, because the ocean does not pause, the stars do not stop moving, the swells do not stop speaking. A navigator cannot sleep the way an ordinary sailor sleeps, because the navigator is the instrument. The body is the compass, and you cannot turn off a compass. When the Hokulea arrived in Tahiti, it was greeted by more than half the island's population. A crowd of more than half of Tahiti's population greeted the crew when they arrived. The emotion of that arrival is difficult to imagine fully. Here was proof, living, breathing, physical, undeniable proof that their ancestors had not simply drifted to the islands by accident, as some Western scholars had condescendingly suggested. They had known. They had navigated. They had carried with them, across thousands of miles of open ocean, the most sophisticated non-instrumental navigation system ever developed by human beings. Maupiailug lived until 2010. Later in life, Mao was respectfully known as a Grandmaster Navigator, and he was called Papa Mao by his friends with great reverence and affection. In 2007, he presided over the first PWO ceremony, the ceremony inducting new Master Navigators, that had been held on Satawal in 56 years. 5 native Hawaiian navigators were initiated, including Nainoa Thompson, who had studied under Papa Mao and gone on to navigate the Hokulea on dozens of subsequent voyages. The Hokulea has sailed over 150,000 nautical miles since 1976 using traditional navigation, including a circumnavigation of the globe completed in 2017. 150,000 nautical miles under the stars by feel, by memory, by the accumulated wisdom of a tradition that stretches back so far into human history that its origins are indistinguishable from the origins of seafaring itself. The living library, it turns out, was not lost after all. It was only sleeping, waiting for someone with the courage and the love to wake it up. Part 9. The Signs of Arrival. There comes a moment on every long voyage when the ocean begins to change. It is subtle at first, almost imperceptible, but a navigator who's been paying close attention, who's been reading the water and the sky and the wind for days, begins to feel something new in the accumulated information around them. The air is different, richer somehow, more complex. There is something in it beyond the clean, simple salt of the open ocean. Something organic, the smell of soil, of vegetation, of the particular green and wet complexity of a living island. The water is different, a slight change in colour, greener now, the deep indigo giving way to something warmer, something that suggests the presence of a shallow continental shelf or a reef system below. The birds are different, more of them, more varieties, and they're flying in the same direction, insistently, with growing regularity, all heading toward a single point on the horizon. And the swells are different. The long-distance swell from the east is there, as it has always been, but its character has changed. It arrives at a very slightly different angle than it did yesterday. It has been bent, refracted by the presence of something massive and solid that the navigator still cannot see but can already feel. After arriving close to their navigational reckoning, navigators would begin to pinpoint a location using sightings of birds, ocean currents, cloud formations, and refractions of shallow water on the underside of clouds. Reflections on the underside of clouds. Islands in the Pacific are often surrounded by lagoons, shallow, brilliantly turquoise expanses of water where sunlight reflects off white sand and coral with extraordinary intensity. On a cloudy day, this reflected light can illuminate the underside of the clouds above the island, giving them a distinctive greenish or pale glow that is visible from many miles away, long before the island itself rises above the horizon. Clouds over islands produce unique cloud formations, and lagoons can give clouds a green tint. A navigator who knows what to look for can read this, can look at a particular cloud far away and say, beneath that cloud there is a lagoon, there is white sand, there is shallow water catching the light, there is an island, and the clouds themselves sometimes accumulate differently over islands than over open ocean. Land heats up faster than water during the day, creating convective columns of rising air that form clouds. A single cloud standing relatively still over a particular point on the horizon, while other clouds drift with the wind, can be a sign that something solid is holding it in place. Something that rises above the water and creates its own micro-weather. Koa watches all of these signs accumulate. He watches the birds, he watches the clouds, he checks the water colour, greener, definitely greener now. He lies in the hull one more time and confirms what the swells have been telling him for the last few hours. The eastern swell is arriving at a slightly different angle. Something is in the way. He sits up, faces forward. There is nothing visible on the horizon, just the flat, unbroken line of sea-meeting sky, the same line that has been there for days, the same line that has offered nothing to the eye that the eye could recognize as land. But Koa knows. He turns to Rua. "We are close," he says. The old man looks at him for a long moment. Then he nods. One single, slow, unhurried nod. "What do you see?" Rua asks. Koa takes a breath. The water is green. The birds are flying north. The eastern swell is bending. It is coming from the northeast now, not the east. And those clouds, he points to a particular cluster on the horizon, are not moving with the wind. They are staying in one place. Another pause. "Land," Koa says. "North, not far." Rua is quiet for a moment that stretches out long and gentle and unhurried over the quiet water. "Not far," he agrees. Part 10. The Art of Memory. It would be a mistake to think of what Rua has been teaching Koa as a collection of techniques, a toolkit, a set of methods to be applied in sequence. What he has been teaching is something older and more essential than technique. He has been teaching attention. He has been teaching presence. He has been teaching the radical, revolutionary, quietly transformative act of paying complete and continuous attention to the world around you. The navigators of the Pacific did not use their minds the way a computer uses its processor, running calculations, consulting databases, executing algorithms. They used their minds the way a musician uses their hands, through years of practice, through deep embodied familiarity with their instrument, until the knowledge was not something they thought but something they were. Traditional wayfinding techniques were passed down for generations, often hidden in songs and stories. Songs and stories. Not textbooks, not manuals, songs, because songs have rhythm, and rhythm is what carries knowledge into the body. A song teaches you not just the information, but the feel of the information, the cadence, the sequence, the relationship between one piece of knowledge and the next. A navigator who knew the star paths in the form of a chant could recite them in the dark, could feel the rhythm of the voyage in the rhythm of the words, could let the song guide the body through the night the way a current guides a canoe through the sea. This is why the knowledge survived for thousands of years without being written down. Not despite the lack of writing, but in some ways because of it. Written knowledge is static. It sits on a page and waits. Oral knowledge is alive. It lives in the mouths and the muscles and the memories of living people, and it changes and grows and deepens with each generation that carries it. A navigator who has sailed a route 10 times knows it better than the navigator who has only read about it. And the navigator who has sailed it 50 times, whose body has felt the particular swells of that particular passage dozens of times, whose nose has smelled the particular air of that particular island approaching from 50 miles away, knows it in a way that no text could capture. The Phoenicians, those master mariners of the ancient Mediterranean who were among the first in the Western world to develop true ocean navigation, passed their knowledge the same way. The Phoenicians relied on natural features on coastlines, the stars, and dead reckoning to guide their way and reach their destination. This knowledge was passed down through generations via oral tradition until it eventually became codified in written form during later periods. Oral tradition, living knowledge, the gift of one generation's experience to the next, carried not in containers of clay or papyrus, but in the irreplaceable container of a human mind. Dead reckoning, the technique of estimating your current position based on your known starting position, your speed, your heading, and the time elapsed, is another piece of this tradition that deserves a moment of contemplation. Dead reckoning factors in speed, time, and direction of travel. Ancient navigators estimated their speed by watching how quickly debris or small floating objects passed the hull. They tracked their heading by the stars, they counted the days, and they maintained in their minds a continuously updated estimate of where they were, a running calculation that they revised with every new piece of information, every star observation, every swell reading, every bird sighting. It was not foolproof. Small errors accumulated. The current could push you off course without you immediately realizing it. Dead reckoning does not account for ocean currents and wind, so ships using dead reckoning could still go astray even when their calculations were correct. This is why the holistic approach of traditional Pacific navigation was so superior in practice. It used dead reckoning as one tool among many, constantly cross-checking it against the physical evidence of the ocean itself, the swells that confirmed or challenged the estimated position, the birds that implied the presence of land or its absence, the watercolour and temperature that spoke to depth and current and proximity to shore. It was a system of redundancy so thorough, so elegantly designed, that its practitioners could navigate across an ocean the size of the Pacific with a reliability that European observers initially dismissed as impossible, and then, when confronted with the evidence of its results, were forced to acknowledge as one of the greatest intellectual achievements in human history. Polynesian navigators achieved the most remarkable feat of geographic exploration in human history. Over approximately 2,000 years, they settled virtually every habitable island in the Pacific Ocean, an area of roughly 10 million square miles, using no instruments beyond their knowledge of stars, ocean swells, wind patterns, and the behavior of birds and marine life. 10 million square miles, every habitable island, no instruments, the human mind fully deployed, fully trained, fully paying attention. This was all they needed. Part 10b, the moon, the sun, and the in-between hours. Before we continue with Koa's journey toward its conclusion, let us pause here in the Mu'e, Wichita of the ocean, in the middle of the teaching, and take a moment to think about two things that have perhaps not received enough attention yet: the sun and the moon. Navigation by night and navigation by stars is the part of the old tradition that feels most romantic, most evocative, most poetically suited to a story told in quiet darkness. And the stars are indeed central. But the daytime sky offered its own navigational tools, and they were just as important. The sun first. During the day, the sun traces a predictable arc across the sky, rising somewhere in the east, reaching its highest point at midday, which is always due south in the northern hemisphere and due north in the southern hemisphere, and setting somewhere in the west. This arc changes slightly with the seasons. The sun rises farther north in summer, farther south in winter. But the pattern is consistent enough that a skilled navigator can use the sun's position throughout the day to maintain their heading with considerable accuracy. During the day, the Vikings used the sun as a primary navigational tool. They observed its position at noon to determine their latitude, and used a sun compass to maintain their bearing. The noon observation was particularly valuable. At the moment when the sun reached its highest point in the sky, its meridian transit, a navigator using a sun compass could cast a shadow that pointed precisely north or south. By noting the length of that shadow, they could also estimate their latitude. This is the same fundamental principle as star navigation, just performed with the daylight sky rather than the night sky. The sun, like Polaris, can tell you how far north or south of the equator you are, if you know how to look. And for those moments when the sun was obscured, hiding behind cloud or positioned at an awkward angle, or already below the horizon while twilight lingered, the Vikings appear to have had their extraordinary sunstone. The sunstone is a crystal, likely Iceland spar, that has a remarkable optical property. When you look through it at a patch of sky and rotate it, the light changes based on the polarization of skylight. And the direction of skylight polarization is always related, in a specific and predictable way, to the position of the sun, even when the sun itself is hidden by cloud or has dropped below the horizon. Researchers conducted numerous experiments to test the possibility that Vikings used the unique properties of these crystals to navigate their way across the ocean, and found that they can be beneficial navigational aids when the skies are blanketed with clouds. 3 steps. Hold the crystal to the sky. Find where the light symmetry indicates the sun's position. Use a shadow stick to translate that position into north. 3 steps, and you have orientation from a piece of rock and a patch of cloudy sky. The moon also offered navigational information, though it is the most complex and least reliable of the celestial bodies for this purpose. The moon's position in the sky changes dramatically from night to night as it goes through its monthly cycle, unlike the stars, which return to the same positions reliably, or Polaris, which barely moves at all. An experienced navigator who knew the moon's cycle could use its position as a rough directional reference, but it required a level of astronomical knowledge that went beyond simple star recognition. The ancient Greeks and Arabs both had sophisticated lunar astronomy. The Arab navigators who dominated the Indian Ocean trade routes from roughly the 8th century onward had developed detailed knowledge of the moon's movements. Partly for religious purposes, the Islamic calendar is lunar, and the precise timing of religious observances required accurate lunar observation, and partly for navigation. The Arab Empire significantly contributed to navigation and had trade networks extending from the Atlantic Ocean and Mediterranean Sea in the west to the Indian Ocean and China Sea in the east. The Arab Kamal, already mentioned, was primarily used to measure the altitude of Polaris, but the same instrument could be used to measure the altitude of the moon, or of any other celestial body whose position the navigator was trying to track. Arab astronomy was well developed in its own right, and this was reflected in their navigation of the Indian Ocean. Arab navigators also developed the quadrant, originally a device for astronomical observation, that was adapted for navigation, allowing them to measure celestial altitudes with greater precision than the simple Kamal permitted. For Rua and Koa, the moon is simply another piece of information, another voice in the conversation that the sky is always having with those who know how to listen. During the half-moon phase, the lit edge of the moon always faces the sun, which means the moon itself can be used to approximately locate the sun even in the middle of the night, and from there to derive east, west, and north. During the full moon, the moon rises in the east at roughly the same time the sun sets in the west, providing a directional reference throughout the entire night. During the crescent moon, its thin arc points in a direction that a skilled observer can use to identify the general direction of the sun below the horizon. The sky is never silent. Even when it appears featureless, even when it offers nothing obvious to the eye, it is always speaking. The navigator's task is never to find silence in the sky, but to learn enough of its language that the speaking becomes comprehensible. Rua teaches this to Koa on a morning when thin, high cloud covers much of the sky. softening the sun to a bright blurriness behind gauze and making the shadows indistinct. "How do you find north today?" Rua asks. Koa thinks about it. The sun is behind cloud, the stars are invisible, the day is overcast, the horizon is clear, but there is nothing in the sky above it that obviously says north. He looks at the water, he feels the wind. He traces in his mind the direction of the dominant swell, east-southeast, as it has been for 3 days. The swell, he says, it comes from the east-southeast, so northeast is, he points, there. And north? He adjusts the angle slightly, points. Rua watches him without expression for a moment. And how do you know the swell is still coming from the east-southeast? Perhaps the storm that made it has moved. This is a harder question. Koa thinks about it seriously. Because it has the same period as yesterday, he says finally, and the day before. A new swell from a different storm would have a different period. This one hasn't changed. It's the same storm, still sending its waves. Rua is quiet. "You learn," he says finally. Hurti 11. The world inside months have passed since Koa first stepped into Rua's canoe in the darkness before dawn, and heard the old man say that he would not need to know where they were going. He understands those words differently now. He understands that navigation, at its deepest level, is not about knowing where you are going. It is about knowing where you are, right now, in this moment, in the continuous unfolding present of a voyage that is always happening in real time, always requiring your full attention, always rewarding it. He understands that the ocean is not a blank space between the place you have been and the place you are going. It is a place itself, a living, information-rich, constantly speaking environment that has been carrying human beings from island to island, from shore to shore, from one world to another, for as long as human beings have been bold enough to push off from the land and trust the water beneath them. He understands that the stars are not decorations in the sky. They are a map, not a flat, static map drawn on paper, but a living, three-dimensional, constantly moving map that contains more information than any paper chart ever could. A map that shows not just direction but latitude, not just latitude but season, not just season but the full connected architecture of the natural world above and around and beneath any point on the surface of the earth. He understands that the wind is not just weather, it is a language, and that language has a grammar, the trade winds, the monsoons, the seasonal patterns, the local variations, that once learned becomes as readable as speech. He understands that the ocean swells are not obstacles, they are roads, invisible, uncountable, constantly moving roads, each one beginning somewhere far away and ending somewhere equally far away, and each one carrying in its shape and direction and period the memory of where it came from and information about what it will encounter on the way. He understands that the birds are not just birds, they are messengers, intermediaries between the sailor and the land they cannot yet see, carrying information that no other instrument could provide about the presence and direction of shores still beyond the horizon. And he understands something deeper than any of these specific things. He understands that the natural world, the whole interconnected, marvelously complex natural world, is not a backdrop against which human life takes place. It is a companion, a partner, a conversation partner of extraordinary patience and generosity, always speaking, always offering information to those who have learned to listen. The navigators who crossed the Pacific before anyone put a single mark on any chart were not operating in a world of ignorance. They were operating in a world of profound, intimate, earned knowledge. They had learned through thousands of years of practice and observation and teaching to read the world as fluently as you read these words, and the world had rewarded their attention with the ability to cross the greatest ocean on earth, in wooden boats, without instruments, without charts, and arrive reliably, precisely where they intended. They did not conquer the ocean. They listened to it. They did not impose their will upon the sea. They learned its language. They did not sail in spite of not having maps. They navigated so deeply, so thoroughly, so intimately with the living world around them that they never needed a map in the first place. But let us pause here and give credit to one more group of navigators who deserve a place in this story, a people who, though separated from the Pacific Islanders by thousands of miles and entirely different oceans, developed their own extraordinary tradition of maritime knowledge through observation, memory, and the willingness to trust what the natural world was telling them. The Phoenicians were, by many accounts, the greatest mariners of the ancient Mediterranean. They came from the narrow coastal strip of the Levant, the region of modern-day Lebanon and parts of Syria and Israel, a land so hemmed in by the mountains on one side and sea on the other that the ocean was never a barrier to them, but always an invitation. They became sailors in the first place because of the topography of their homeland, the narrow mountainous strip of land on the coast. Travelling between settlements was much easier by sea, especially when carrying cumbersome cargo. By around 2000 BCE, the Phoenicians had already developed the observational navigational techniques that would make them legends in the ancient world. The first Western civilization known to have developed the art of navigation at sea were the Phoenicians, about 4,000 years ago. Phoenician sailors accomplished navigation by using primitive charts and observations of the sun and stars to determine directions. But it is what the Phoenicians could do without instruments that is most remarkable. The Phoenicians did not have the compass or any other navigational instrument, and so they relied on natural features on coastlines, the stars, and dead reckoning to guide their way and reach their destination. The most important star to them was the pole star of the Ursa Minor constellation. They sailed beyond the Mediterranean, through the Strait of Gibraltar, which they called the Pillars of Hercules, out into the Atlantic. They navigated the coast of West Africa. There is credible historical evidence that a Phoenician fleet commissioned by the Egyptian pharaoh Necho II around 600 BCE circumnavigated the entire continent of Africa, a voyage of many thousands of miles taking approximately 3 years, without charts, without compass, guided only by the stars, the sun, the winds, the currents, and the accumulated knowledge of generations of Phoenician navigators. The Greek historian Herodotus reported this voyage with a mixture of admiration and mild skepticism. He found particularly difficult to believe the navigators' claim that as they sailed around the southern tip of Africa, the sun appeared on their right to the north, rather than their left to the south. Modern readers, of course, recognize this as exactly what would happen when sailing westward through the southern hemisphere. The sun is to the north. Herodotus did not believe it because he had never been that far south himself, but the Phoenicians had, and they reported what they actually saw. The Greek term for the Ursa Minor constellation, Phoenica, was named in honor of their navigational mastery. The Greeks who named that constellation were acknowledging something important, that the Phoenicians had used that star more skillfully, more reliably, and to greater effect than any other people then known. It was a compliment written into the sky, preserved forever in the names of the stars. This knowledge was passed down, as all the great navigational traditions were passed down, not in writing but in oral tradition, in the accumulated experience of navigators who had sailed the same routes, in the stories told by experienced sailors to apprentices on the deck of a ship, in the practical, embodied knowledge that only comes from doing the thing repeatedly until it becomes part of who you are. Part 12. Coming Home. The island appears just as Koa knew it would. Not all at once, not dramatically, not in a sudden revelation of cliffs and palms rising sharply above the horizon. It appears gradually, the way most true things appear, when they appear to those who have been paying attention, slowly, softly, incrementally. First just the smells, the green complexity of vegetation, the mineral sharpness of coral, something warm and specific, the particular smell of this island, which is different from every other island the way every face is different from every other face. Then the birds, more of them now, white terns spiralling in the air above a point that is still below the horizon, their wings catching the light, flashing, turning, 30 miles away, 20, hard to say, then the clouds. One particular cloud sitting very still while its neighbours drift southward in the steady trade wind. A stationary cloud held in place by the invisible column of rising air above the sun-warmed land beneath it. Then the colour of the water, greening now, genuinely, clearly green. The particular turquoise green of a tropical lagoon showing through the gap in a reef, luminous and warm, like a window into sunlight from below. And then, finally, the land itself, a dark line at first, a low shadow on the horizon that might be mistaken for another cloud, except that it does not move, does not shift, does not change its shape with the wind. It simply sits there, solid and patient, exactly where the ocean has been saying it would be for the last several hours. Koa watches it grow. He does not feel what he expected to feel. He expected triumph, the sharp, bright feeling of having done something and done it right. He expected pride, maybe even a little surprise despite himself. What he feels instead is quieter than any of that. He feels something like gratitude, a warm, spreading, very quiet gratitude directed outward. toward the stars that guided him, toward the swells that spoke to him, toward the birds that confirmed what he already knew, toward the old man sitting silently behind him, who has given him the greatest gift that one human being can give another, the ability to be present in the world, the ability to listen, the ability to read the living language of the natural world around them, with enough fluency that the world becomes not a dangerous, featureless, indifferent expanse, but a home that extends in every direction as far as the stars can reach. Rua says nothing, as the island rises slowly above the horizon ahead of them. He does not need to. The canoe moves forward on its long, unhurried swells, and the island grows, and the air smells of everything that has ever meant home, and the stars, hidden now behind the brightness of the afternoon sky, are waiting, as they always wait, for the darkness that will come again tonight, and the night after, and every night for as long as there are navigators who know how to look up and read them. Part 12b. Every sea has its sailors. It would be a kind of injustice to this story if we left it confined entirely to the Pacific, because the truth is that extraordinary non-instrumental navigation was not a Pacific phenomenon alone. It was a human phenomenon. Wherever there was ocean, there were people who learned to read it, and the specific methods they developed reflected the specific oceans they were reading, the specific stars they could see from where they lived, the specific winds and currents and birds and creatures that inhabited their particular corner of the world. Let us spend a few quiet minutes drifting across some of those other oceans, other sailors, other traditions, other ways of listening to the world. The Arabs first, the sailors of the Indian Ocean who built one of the most sophisticated maritime cultures in the history of the world across the 1,000 years from roughly 700 CE onward. The Indian Ocean is not like the Pacific. It is a more enclosed space, bounded by Africa to the west, the Arabian Peninsula and India to the north, Southeast Asia to the east, and the cold Southern Ocean to the south. It is also unusual among the world's major ocean basins in one crucial respect: its winds reverse. The monsoon, that great seasonal reversal of wind direction, dominates the Indian Ocean completely. In summer, the wind blows strongly from the southwest. In winter, it reverses and blows from the northeast. This reversal is so reliable, so consistent, so deeply embedded in the seasonal pattern of the Indian Ocean that mariners who understood it could plan their voyages around it as precisely as a modern airline plans its flight schedules. Arab sailors had this understanding. They had mapped the monsoon system in intimate detail, not on paper necessarily, but in the living knowledge of a maritime culture that had been sailing these waters for centuries. An Arab navigator planning a voyage from the Persian Gulf to the coast of India knew that he needed to depart in the winter to take advantage of the northeast monsoon and return in the summer when the southwest monsoon would carry him home. He knew not just the general direction of these winds, but their character at different times of the season, when they were strongest, when they were most reliable, when the transition periods between the two monsoons made sailing difficult or dangerous. The Arab navigators also developed the kamal, that simple but elegant instrument of bone or wood and knotted string for measuring the altitude of Polaris. The kamal itself was simple to construct. It was a rectangular piece of either bone or wood which had a string with 9 consecutive knots attached to it. Each knot corresponded to a known latitude, to a specific port or island or point on the coast where the navigator needed to arrive. To use it, you held the wood at arm's length with the string taut between the board and your nose, then looked at Polaris over the top edge of the board. The knot at your teeth when Polaris appeared exactly at the board's top edge told you your latitude. Simple, portable, reliable, and requiring no materials that could not be found on any trading vessel in the Indian Ocean. Across the Indian Ocean and into the Chinese seas, Chinese navigators were developing their own sophisticated tradition. The Chinese were among the first to use the magnetic compass for navigation, independently of European developments, sometime around the 11th or 12th century. But before the magnetic compass, Chinese sailors had been reading the same stars, the same currents, the same monsoon patterns as their Arab counterparts. The Chinese and Europeans independently invented the compass around the 11th century, and European sailors also developed navigational instruments such as the cross staff and quadrant in the 12th and 13th centuries. But the magnetic compass, significant as it was, did not replace the reading of the natural world. It supplemented it. Chinese navigators who had a compass still watched the stars, still felt the swells, still observed the birds and the colour of the water, and the floating debris that told them where they were in relation to land. The compass told them which way north was on a cloudy night, but the stars told them where they were in relation to their destination. Both pieces of information were necessary, neither made the other obsolete. In the North Atlantic, meanwhile, the Norse were navigating some of the most challenging waters on Earth. The North Atlantic is not kind, it is cold, grey, frequently stormy, and subject to weather patterns that can obscure the sky for days or weeks at a time. The summer nights at high northern latitudes offer barely any darkness at all. In Scandinavia and Iceland, the summer sky barely gets darker than a deep twilight, making star navigation difficult or impossible for months. These were the conditions under which the Norse navigated their longships to Iceland, Greenland, and eventually to North America, and they developed a suite of techniques specifically adapted to these challenging conditions. The sunstone for cloudy days, as we have discussed, the sun compass for clear days, using the shadow of a central gnomon to track the sun's arc, Polaris and the Big Dipper for clear nights, and the flight of birds, specifically the Norse tradition of carrying ravens on voyages and releasing them to find land, a technique borrowed from, or perhaps independently discovered alongside, similar practices in other seafaring cultures. Steering westward across the North Atlantic in summer, they measured the distance between Polaris and the horizon to determine latitude. This measurement of Polaris's height above the horizon was the Norse navigators' most fundamental skill. It allowed them to sail by latitude, to establish the latitude of their destination, and then simply sail along that latitude until they arrived. This technique was called sailing the parallel. It was elegant in its simplicity. You didn't need to know your exact east-west position at any moment. You just needed to know that if you kept Polaris at the correct height above the horizon, you were on the correct latitude line, and eventually you would hit the coast of wherever you were going. Leif Erikson's voyage to Vinland, to the coast of North America, somewhere around Newfoundland, was likely accomplished using exactly this technique. Keep Polaris at the right height, keep sailing west, hit the coast, explore. The ancient Greeks too had their navigational traditions. Homer's Odyssey, one of the oldest works of Western literature, describes celestial navigation with a matter-of-factness that tells you this was ordinary knowledge for its intended audience. Written records of navigation using stars go back to Homer's Odyssey, where Calypso tells Odysseus to keep the bear, Ursa Major, on his left as he sails eastward. Keep a specific constellation on a specific side of your boat. It doesn't require instruments, it doesn't require sophisticated training, it requires knowing which way is east and knowing where the bear is. Anyone who grew up with the Mediterranean night sky would know both of these things. The ancient Minoans, the civilization that flourished on the island of Crete from roughly 3000 to 1100 BCE, left architectural evidence of their celestial knowledge. Their palaces and mountaintop sanctuaries exhibit architectural features that align with the rising sun on the equinoxes, as well as the rising and setting of particular stars. The Minoans made sea voyages to the island of Thera and to Egypt. Both of these trips would have taken more than a day's sail for the Minoans, and would have left them travelling by night across open water. Here the sailors would use the locations of particular stars, especially those of the constellation Ursa Major, to orient the ship in the correct direction. Ursa Major, the Big Dipper, that same constellation whose two outermost stars point reliably toward Polaris, the fixed North Star, the same constellation that the Phoenicians called by a name that became, in Greek, Phoenica, the same stars that Viking navigators watched, and Greek navigators watched, and Arab navigators watched, and, likely, the first human beings who ever looked up at the night sky and thought, I wonder where that leads. All of them, across all those centuries, across all those different oceans and cultures and technologies, were doing the same fundamental thing. They were paying attention. They were learning the language of the world around them, the language of stars and wind and water and birds, and then using that language to find their way across the largest, most featureless, most disorienting environment that the surface of this planet has to offer. And they succeeded. Everywhere they tried, they succeeded. The Minoans reached Egypt, the Phoenicians circumnavigated Africa, the Arabs built a trade empire that stretched from the Atlantic to the Pacific, the Norse found North America, and the Pacific Islanders settled every habitable island in the largest ocean on Earth. A navigational achievement so extraordinary that it still takes the breath away to fully appreciate. All of this astonishing human achievement, without maps, but with something better, with knowledge so deep and so carefully earned and so lovingly transmitted from one generation to the next, that it became more reliable than any map could ever be. Because a map can be lost, a map can be soaked through, torn, burned, destroyed. A map is always, at best, a simplified model of a world that is infinitely more complex than any flat surface can contain. But a navigator who has learned to read the world, who has made the ocean and the sky and the wind and the birds and the water a part of themselves, an extension of their own awareness, carries something that cannot be lost or soaked or torn or simplified. They carry the world itself as a living thing inside them, and the world in return always knows the way home. Tonight, if you step outside and look up at the sky, you will see the same stars that guided the first sailors across the Pacific, the same Polaris sitting steady above the northern horizon, the same Southern Cross tilted in the southern sky, the same Orion with his perfect belt of 3, rising due east just as he has always risen. The stars have not changed, the trade winds still blow, the ocean swells still travel their ancient paths across the deep basins of the Pacific and the Indian Ocean and the Atlantic, carrying their information about distant storms and the shapes of hidden islands the same way they always have. What's changed, briefly, in the long story of human seafaring, was our willingness to listen. For a period of time that amounts, in historical terms, to barely a blink, we decided that instruments were better than bodies, that charts were better than memory, that technology was more trustworthy than knowledge earned through years of devoted attention to the natural world. And we were not entirely wrong. Modern navigation is faster and more precise and more reliable in many ways than the ancient alternatives. The GPS satellite knows where your ship is with an accuracy that no amount of star reading could match, but something was also lost. Or rather, something was set aside. Something was allowed to go quiet, to sleep, to exist only in the memories of a shrinking number of people on a shrinking number of islands, held there by love and stubbornness and the deep, human refusal to let beautiful things entirely die. And then, people like Mao Pielug said, no, this knowledge deserves to live, and it does. Today, the Hokulea has sailed over 150,000 nautical miles under the stars, guided by the same techniques that guided the first Polynesian voyagers across the Pacific 2,000 years ago. Nainwa Thompson, the first modern-day Polynesian to use wayfinding for long-distance open ocean voyaging, navigated the Hokulea on voyages of over 2,500 miles, and traditional navigation is now being taught in schools throughout Hawaii and the Pacific. The living library is being written again. The songs are being sung. The young navigators are lying in hulls, feeling the swells through the wood with their stomachs, and learning to read what the ocean has always been trying to say. And on a small island somewhere in the Pacific right now, a child might be lying on their back on a warm night, looking up at the stars, feeling the trade wind on their face, listening to the waves, learning to be still, learning to pay attention, learning that the world is full of language, if only you are quiet enough to hear it. The stars return each night, steady and unchanged. The ocean breathes in its slow, ancient rhythm, and somewhere between the stars and the water, the old knowledge lives on, in the bodies and the minds and the careful, loving attention of those who learned that the greatest compass ever made was always already inside them. And on that note, I hope tonight's journey brought you some peace, some stillness, maybe the same feeling Koa felt watching that island rise above the horizon. Not triumph, not drama, but that very quiet, very deep gratitude for a world that is, if you are paying attention, endlessly and generously speaking. If this video gave you something tonight, a little wonder, a little calm, a gentle drift toward the edge of sleep, I would love it if you left a like. And if you are new here and you want more slow journeys through extraordinary histories and remarkable places, please subscribe. We do this every week, and there is always somewhere new to go. Sleep well, the stars are out, and somewhere the ocean is breathing. Good night.